Alright, so next up we ought to look at the protein efficiency ratio. Remember, these are the parameters of the quality of the protein quality that we're looking at. So we just looked at biological value, which is BV, and now we ought to look at the protein efficiency ratio. So it is a less commonly used parameter for assessing the protein quality, and by definition you can say it is the gain in body weight for each unit weight of protein ingested. The gain in body weight for each unit weight of protein ingested. This is where we see that the amount of the dietary protein used for maintenance is ignored, but you're just going to look at the one that is going to be in charge with the growth of the body, gaining of the body. So this is where we can use that formula there that says protein efficiency ratio is equal to gain in body weight over the protein's weight. Since we're saying by definition it is the gain in body weight for each unit weight of protein ingested. So eggs, milk, and meat have a high protein efficiency ratio of about 2.5, and then if you look at things like legumes, lentils, cereals, and nuts, they have a protein efficiency ratio of between 0.5 to 2.5. I mean, we see gelatin coming back again with a protein efficiency ratio of less than 0.5. So remember that it was among the animal proteins that were exceptional of that statement that we said that animal proteins have a higher BV, so gelatin was an exception. So we see it here again, also having a low protein efficiency ratio. So the next thing that we can look at there is chemical store, and with chemical store we're looking at the essential amino acid content, which can be expressed using this formula that says milligrams of limiting amino acid in 1 gram test protein over the milligram of the same amino acid in 1 gram of the reference protein. So kind of comparing the protein that we want to test for with a reference protein, like a standard known protein, and then the egg protein is taken as a reference protein because its chemical store is 400. So we see egg protein being quite good of a quality protein because even the BV was high, like 96. So next thing that we can look at there is the digestibility coefficient. So with the digestibility coefficient, so from the word digestibility, so it refers to the percentage of the ingested protein absorbed into the bloodstream, so that is after digestion in the GLT. So the percentage of the ingested protein absorbed into the bloodstream. Yeah. And then from there we can look at the net protein utilization, NPU, which is a measure of utilization of dietary protein for synthesizing bad proteins. Okay, so this is where we look at the nitrogen retained over the intake of nitrogen. So note that this is the difference from the previous BV formula that we had that said what? So the BV formula said nitrogen retained over nitrogen absorbed, but NPU formula is saying nitrogen retained over intake of nitrogen. Alright, so that's something to note. High heeled Zilengalanda. So yeah, so this NPU is actually even better than the biological value because it takes into account the digestibility factor also, and then looking at it mathematically, you get to see that the net protein utilization is it's actually dependent on both the digestibility coefficient and the biological value BV using this formula here. So yeah.